Divisibility principles. So let's see what is division to. We know that dividend is equal to quotient into divisor plus remainder. Okay, so that is we are doing that is when we divide a number, that number is called dividend. Suppose we are dividing the number by another number, that number is called divisor. Okay, so dividend by divisor is equal to, write quotient plus remainder by divisor. Okay, suppose we need to divide the number 122 by 7. Okay, so here 122 is the dividend, 7 is the divisor. So by long division method, let's divide 122 by 7. So how will you divide a number by another number? So here you have to take a number which is greater than 7 in the dividend. So that number is 12 here. So we know that 1 7s are 7. Okay, so 12 minus, if you take 2 7s are 14, that is greater than this number 12. So you have to take the multiple of 7 which is closer to 12 and less than 12. It is 7. So 1 7s are 7. So we write 1 in the quotient. So 1 7s are 7. Next we take the difference of the numbers 12 and 7. That is we divide this, that is we subtract 7 from 12. So 12 minus 7 is 5. So we get 52. Now find the multiple of 7 which is closest to 52 and less than 52. What is that number? It is, we know that it is 7. Okay, so that is number is 49. So 49 is 7 into 7 is 49. So 7 7s are 49. So now 52 by minus 49 is 3. So we can stop here. So this 17 is the quotient. Okay, 3 is the remainder. 122 is the dividend and 7 is the divisor. So this can be written as 17, that is the quotient, plus remainder. Remainder is 3 here by divisor. Divisor is 7. Okay, you can verify this when you multiply these two. What you get? 17 into 7. 17 into 7 is 119. 119 plus 3 is 122 by the denominator of the proper fraction. 3 by 7 is a proper fraction, no? So that is 7. Okay, the same we can do here. We can use this formula also, that is dividend is equal to quotient into divisor plus remainder. Okay, so that is quotient is the 17. 17 into divisor is 7. 17 into 7 plus 3, that is 122. That is the dividend. So remember this rule, division rule, that is dividend is equal to quotient into divisor plus remainder, or dividend by divisor is equal to quotient plus remainder by divisor. Now another important thing, division by 0 is not yet defined. Okay, so 1 by 0, it is not defined. Okay, 100 by 0, it is not defined. So that is in the division of two numbers, if the divisor is 0, its division is not defined. But dividing 0 by any other number is defined. Okay, suppose dividend is 0 and divisor is any number. Let's take 1. It is defined. Its answer is 0. Okay, remember that 0 by 100 is also defined. It is 0. So that is, if in the numerator there is 0, the answer will be 0. If in the denominator it is 0, then its result is not defined. So remember that division by 0 is not defined. Next is division by 1. Division by 1 for any odd number A is the number A. Okay, so that is when we divide a number A by 1, we get the same number A. That is 100 divided by 1 is equal to 100. Similarly, we can write this as 200 divided by 1, that is equal to 200. Okay, 10,143 divided by 1, that is equal to 10,143. So that is division by 1. So when we divide a number by 1, we get the same number. So if that number is A divided by 1 is equal to A. Okay, so remember, division by 0 is not defined and division by 1 is the same number. Division by 1 will give you the same number. Okay. A natural number is divisible by 2. That is divisibility rule on 2. Okay, divisible by 2 if and only if the digit in its units place is either 2, 4, 6, 8 or 0. So what do you call these numbers? 2, 4, 6, 8. These are even numbers. So these numbers are divisible by 2. Okay. So when you want to check whether a number is divisible by 2, you have to check whether the units place of that number are either 2, 4, 6, 8 or 0. If yes, that number is divisible by 2. For example, 1024. Can you say this number is divisible by 2? Look at only the units place of this number. 4 is the units place of the number. 4 is there in the units place of this number. So 4 is an even number. Even numbers are divisible by 2. So this is divisible by 2. This number is divisible by 2. Okay, so check the numbers whether the numbers 2, 4, 6, 8, 0 are there in the units place of the number, then definitely that number will be divisible by 2. Another example, 248. Is it divisible by 2? Yes, look at only the units place number. It is 8. So this number is divisible by 2. Okay, now what about 123? Is it divisible by 2? See the units place number. It is 3. It is not an even number. So it is not divisible by 2. It is not divisible by 2. So remember, to check whether a number is divisible by 2, you need to check whether the digit in its units place is either 2, 4, 6, 8 or 0. And next is divisibility rule on 3. A natural number is divisible by 3 if and only if the sum of these digits is divisible by 3. Okay, for example, let's consider a number 1431. How will you check the divisibility of this number? So we need to check whether this number is divisible by 3. Find the sum of these digits. So the digits are 1, 4, 3, 1. Add these 4 digits. 1 plus 4 plus 3 plus 1. What do you get? 1 plus 4 is 5. 5 plus 3 is 8. 8 plus 1 is 9. Okay. 9 is multiple of 3 or 9 is divisible by 3. Or otherwise you can check what that 9 is there in the multiplication table of 3. In that way you can check. So we can say that this number 1431, that is 1431, is divisible by 3. Okay, so to check the divisibility by 3, you have to find the sum of the digits of the given number and check whether that sum is divisible by 3. Then we can say that the given number is divisible by 3. One more example, 1546. Check whether this number is divisible by 3. For that, add the digits of this number, that is 1 plus 5 plus 4 plus 6. What do you get? 1 plus 5 is 6, 6 plus 4 is 10, 10 plus 6 is 16. So tell what this number is divisible by 3 or not. That is, you have to check whether 16 is there in the multiplication table of 3. No, 16 is not a multiple of 3. So we can say that this number is not divisible by 3. Okay. Another example, 15,246. Add the digits 1 plus 5 plus 2 plus 4 plus 6. 1 plus 5 is 6, 6 plus 2 is 8, 8 plus 4 is 12. 12 plus 6 is 18. 18 is multiple of 3, isn't it? We can see the number 18 in the multiplication table of 3. So this 18 is divisible by 3. So we can say that this number is divisible by 3. That is the divisibility rule of number 3. Now let's check the divisibility rule of number 4. A natural number is divisible by 4 if and only if the number formed by the last 2 digits of the given number is divisible by 4. In the case of 2, we check whether the units place number is divisible by 2. The numbers divisible by 2 are the even numbers 2, 4, 6, 8 and 10. So the units place we have only 0. Okay, and in the case of 4, we check the numbers formed by the last 2 digits of the given number is divisible by 4. Okay, let's take an example, 116. So to check the divisibility by 4, you check the last 2 numbers of the given number, that is 16. 16 is divisible by 4, or 16 is there in the multiplication table of 4. So we can say that this number is divisible by 4. You can check that, divide 116 by 4, you will get the remainder 0. Then we say that the number is divisible by 4, isn't it? So we have 2 4s are 8, 36, 9 4s are 36. We have the remainder 0. So this number is divisible by 4. Okay, so to check the divisibility by 4, you don't want to divide the number by the number 4. You can check whether it is divisible by 4 by looking at the last 2 digits of the given number. Okay, if that number is divisible by 4, definitely the given number will be divisible by 4. Another example, 824. Is it divisible by 4? How will you check that? Consider the number formed by the last 2 digits of the given number. It is 24. Is 24 divisible by 4? Or is 24 there in the multiplication table of 4? Yes, isn't it? So we can say that this number is divisible by 4. Okay, one more example, 1736. Is it divisible by 4? Take only the last 2 digits of the number, that is 36. 36 is multiple of 4, or 36 is divisible by 4, or 36 there in the multiplication table of 4. So we can say that this number is divisible by 4. One more example, 1122. Check whether this number is divisible by 4. Consider only the last 2 digits of the given number, that is 22. 22 is not a multiple of 4, isn't it? So we can say that this number is not divisible by 4. Okay, and next is divisibility by 5. A natural number is divisible by 5 if and only if its last digit is either 5 or 0. We know the multiples of 5, 5, 10, 15, 20, 25, 30, etc. So in these numbers you can see that the units place numbers are either 5 or 0. So if the units place number, that means the last digit of the number is either 5 or 0, we can say that the number is divisible by 5. For example, 155. Units place number, last digit is 5. It is divisible by 5. Okay, now 1200. The last digit is 0. So it is divisible by 5. It is also divisible by 2 also. Okay. So this number is divisible by 5. So it's very easy to check the divisibility by 5. So you need to check only the last digit is either 5 or 0. Then you can say that the number is divisible by 5. Now the divisibility rule on 6. If a number is divisible by 2 and 3, then it is divisible by the product 6. So to check whether a number is divisible by 6, you need to check whether that number is divisible by 2 and 3. Then we can say that the number is divisible by 6. For example, let's take the number 54. So first you need to check whether it is divisible by 2. So you look at the last digit, that is 4. It's an even number. So this number is divisible by 2. Okay. Now what about the divisibility by 3? For that you add the sum of the digits. So that is you add the digits. Okay. That is, you find the sum of the digits. 5 plus 4 is 9. 9 is multiple of 3. So this number is divisible by 3. So if a number is divisible by 2 and 3, we can say that that number is divisible by 6. Another example, 174. So you can see that the units place number is 4. It's an even number. So this number is divisible by 2. Now what about the divisibility by 3? You add the digits. 1 plus 7 plus 4. 1 plus 7 is 8. 8 plus 4 is 12. 12 is the multiple of 3. So we can say that this number is divisible by 3. So the number 174 is divisible by 2 and 3. So the number of 174 is divisible by 6. So that is the divisibility rule by 3. That is, if a number is divisible by 2 and 3, then it is divisible by 6. Next we got the divisibility rule by 8. That is, a natural number is divisible by 8 if and only if the number formed by the last 3 digits of the given number is divisible by 2. 3826. So you look at the last digit, that is units place digit. It is 6. It's an even number. It is divisible by 2. Okay. Now what about divisibility by 3? 3 plus 8, that is add the digits. Okay. 3 plus 8 is 11. 11 plus 2 is 13. 13 plus 6 is 19. 19 is not a multiple of 3. So this number is not divisible by 3. So we can say that this number is not divisible by 6. A number is divisible by 6 if and only if that number is divisible by 2 and 3. Now divisibility rule on number 8. A natural number is divisible by 8 if and only if the number formed by the last 3 digits of the given number is divisible by 8. So now let's recall the divisibility on 2 and the divisibility on 4. So in the case of divisibility divisible by 2, we check whether the last digit is divisible by 2. That is an even number. And in the case of divisible by 4, we take last 2 digits is divisible by 4. And in the case of divisible by 8, you need to take last 3 digits is divisible by 8. Okay. Now let's check some examples. So let's consider 1104. Okay. So for that, to check whether this number is divisible by 8, take the last 3 digits of the number. So we get 104. Check whether 104 is a multiple of 8. Or check whether 104 is divisible by 8. So we can check that 104 divided by 8. 1 8 are 8. 10 minus 8 is 2. 24. 3 8s are 24. Remainder 0. So this number is divisible by 8. So the last 3 digits of the number 1104 is divisible by 8. So the number is divisible by 8. Okay, another example, 18,200. So take the last 3 digits of the number, that is 200. So 200 is a multiple of 8, isn't it? 25 into 8 is 200. Okay, so we can say that this is divisible by 8. $28,301. Take the last 3 digits, 301. It is not a multiple of 8. Okay, so we can say that this number is not divisible by 8. So that is the divisibility rule on number 8. That is, a natural number is divisible by 8 if and only if the number formed by the last 3 digits of the given number is divisible by 8. Now we have divisibility on 10. A natural number is divisible by 10 if its last digit is 0. So that is 10 is divisible by 10, 100 is divisible by 10, 10,000 is divisible by 10, 10,430 it is divisible by 10, because you can see that last digit of these numbers are 0. So we can say that that number is divisible by 10. You can say that this number is also divisible by 2. This number is also divisible by 5 also. Because if we have the last digit is 0, that number is divisible by 2 as well as this number is divisible by 5. Okay, so remember the divisibility by 10, that is the natural number is divisible by 10 if its last digit is 0. Now a natural number is divisible by 11 if and only if the difference between the sums of alternate digits is divisible by 11. Okay, for example, let's take a small example. Okay, so that is 1716. We need to check whether this number is divisible by 11. For that, you have to take the alternate digits. So what are the alternate digits? 1 and 1, and here 7 and 6. So find the sum of these alternate digits. So the sum of these digits 1 plus 1 is 2. The sum of the digits 7 and 6 is 13. Now find the difference between these two numbers. Difference of 13 and 2 is 11. 11 is divisible by 11. So this number 1716 is divisible by 11. Okay, another example. 1,92,379. Okay, so what are the alternate digits? 1, 2, 7. 9, 3, 9. Find the sum of these digits. 9 plus 3, 12. 12 plus 9, 21. Find the sum of the digits. 1 plus 2, 3. 3 plus 7, 10. Now the difference between these two numbers 10 and 21 is 11. It is divisible by 11. So this number is divisible by 11. Another example, 17,436. Okay, alternate digits 1, 4, 6, here 7 and 3. So the sum of digits, alternate digits 7 plus 3 is 10. Here 1 plus 4 is 5, 5 plus 6 is 11. So what is the difference between the numbers 11 and 10? It is 1. It's not a multiple of 11. It's not divisible by 11. Okay. So we can say that 17,436 is not divisible by 11.